Morning, Year 8. So, today's lesson on exercise 6E, introduction to rates. If you are up to that, then this is what the video is going to be about. But otherwise, this session you might be working on 6B, 6C. Remember, chapter 6, learning 6C, which is dividing ratios. That's the main skill I would like you to take. Let's have a look. Introducing rates. So today you're just going to learn, well, what is a rate and how do you simplify them? That's the goal. Okay, that's what you want to do. For those who are very keen, you can try applying and doing problems with exercise 6G, but that's not what we're going to be doing. We're meant to be moving forward onto chapter 8. So on Wednesday, obviously you're going to be on camp, but over the weekend, have a watch of my chapter 8 videos. We're going to try to power through next week when I see you guys again. Okay, so here we go. Let's have a look here. What is rate? So let's do a first example. It says to express each of the following as a simplified rate. Well, first thing is, well, what is a rate? Well, rate is very similar to ratios, except this time you've got a context. Okay, you've got an application or where ratios can be applied, but it's almost like with two quantities simultaneously. So we have a look at this here. A, you can see it says 12 students for 2 teachers. Okay, so 12 students for 2 teachers is like saying two teachers. Now, in terms of ratios, what we're kind of used to is it kind of looks like a 12 to 2 ratio. Okay, so for every 12 students, there's going to be 2 teachers. When they say simplified rate, essentially they want to say, well, and normally when we see rates, we normally write it like this. We say 12 students per 2 teachers. Yeah, we do it like a forward slash. And so normally if we simplify ratios here, we would then say, well, common factor is 2. Highest common factor is 2. So if I divide both sides by 2, you are going to get then 6 to 1. So what that means in translation is that it's 6 students per teacher. This is often the rate that we refer to. Yeah, so it's like 60 kilometers per hour. See, that's a rate. That's a speed that when you're going in a car, when people say, how fast are you driving? You say 60 kilometers per hour. And what that really means is for every 60 kilometers, you have traveled 1 hour. Okay, so that's essentially 60 to 1. That's what it's trying to say. So if I did 2 hours, then since I doubled it, then this now would be doubled as well. So it'd be 120. So I know that in 2 hours, I would have done 120 kilometers. That's why it's called a rate. And it's slightly different to ratios, but I technically usually use the solving component. I use ratios to solve rate problems. Okay? So that's the general idea. So today's lesson, you are learning to simplify and get a feeling of what rates are. So part A, we've got 6 students to 1 teacher. And so how do you know it's simplified? When you get that 1 there. So it's per teacher or per whatever the context is. So we have a look at B now. It says it's $28 for 4 kilograms, right? So if I were to write this as a ratio, essentially it's trying to say $28 to 4 kgs, which technically is like 28 to 4. And if I then reduce that, common factor is 4. So I'm going to write it again. Highest common factor is 4. So if I divide both sides by 4, you can see now 1, and that's a 7. So it's a 7 to 1 ratio. So if we were to write the rates now, the rates would then be it's $7 per kilo. And that's what you see when you go buy food in Coles or something like that. They would say, it's $7 kilo. How many of these fruits do you want? If you go to Victoria Market, they're shouting this out. They're like, $7, $7, $7 per kilo, something like that. That's essentially what you're doing here, right? So that's what rates are. Let's have a look at another problem. Let's let's now try to put it into context. So now you got Tom was 120 centimeters tall when he turned 10 years old. So I'm going to write here 120 cms when he that tall, and when he turned 10 years old. So you can kind of think of it as 10 years. So it takes him for every 10 years, it seems like it's 120 centimeters. So now it says he was 185 centimeters tall when he turned 20 years old. So it seems like 20 years, he was 185 centimeters, right? Now they want you to find Tom's average rate of growth per year between 10 and 20 years of age. So let's not get confused with how they're wording it. Let's break it apart. So between 10 and 20 years of age, we know that essentially means, how long is that if I asked you? Between 10 and 20 years of age, that is 10 years, isn't it? From 10 to 20 years. So over 10 years. Now what they want you to do, and this is the key part that you needed to pay attention to understand what the question wants you to do. It says average rate of growth. So growth is how fast you grow in terms of your height per year. Do you see that? That language there? This one's trying to talk about growth per year. Can you see that? That's what they're trying to get to. So first thing we need, okay, what we need is we need a rate. So over this 10 years, how much has Tom grown overall? Yeah, so in 10 years, from 10 to 20 years old, he went from 120 centimeters to 185 centimeters. So after 10 years, he has grown 120 to 185. That's a 65 centimeter growth. Can you see that? So essentially the rate would imply that it's 65 centimeter growth per 10 years. So now we've got the rate. See how I extrapolated the information? That's the skill for the next part. Okay, so once you can do that and you're up to this point, this is pretty much similar to what we just did at the beginning. It would be then, 65 to 10. And if I want to know what it is for 1, well, we can see that if I divide this by 10, and if I divide this, and you don't have to find a highest common factor, actually. Your aim is to get that 1. So I can see that 10 divided by 10 gives me the 1, and then 65 divided by 10, use your calculator, or you don't have to, and it's 6.5. So what this implies, once you've worked out that ratio, what that implies, it's 6.5 centimeters per year, or 6.5 centimeter growth per year. That's my rate. That's the rate that I'm working with. Okay, so just going back, because I realized I mentioned about highest common factor over here. You don't have to. The aim is to get from here to 1. The aim is to get to 1. Okay, so you don't need the highest common factor. The 4 here, 4 divided by 4 gets you 1. Okay, oops, I shouldn't have rubbed that out. Divide 4. So your aim is always to get to that per. Every time they say per, so per year, per kilo, per what was the other one? Per teachers, then your aim is to reduce it down to 1 because it's a rate. So when it's rate, we always need this to be 1, and it's okay to have this as a decimal. Okay. All right. So I hope those 2 examples help you to get you going for exercise 6E. It's an introduction to rates. If you want to really get the feel of it, then technically 6G is also meant to be part of the syllabus, but we are really behind given the interruption of the camp and all that. So we're going to move on to chapter 8 pretty soon. So on the weekend after your camp, I do expect you to at least watch the video to have an idea of chapter 8. Okay, but it's easy. It's statistics. Most students pick that up pretty easily. But thank you again. I appreciate it. Have a wonderful day, and I'll see you next week.